Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to click on the end of the problem where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 2 to the power of x is equal to 3 to the power of x. So now I want to find the value of x. So for my solution here, first start with 2 to the power of x is equal to 3 to the power of x. Now, I'm going to be taking the log of base 2 on both sides. So now I have log base 2 of 2 to the power of x is equal to log base 2 of 3 to the power of x. Now, an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this would equal b times log a. And the reason this property is so important is that, let's say we have the problem 7 to the power of x is equal to 9. Well, right now it's really hard to solve for x because x is an exponent and we know that x is going to be a decimal because 7 to the power of 1, this is equal to 7, and 7 to the power of 2, this is equal to 49. And 9 is somewhere in between 7 and 49, meaning x is somewhere in between 1 and 2. However, it's really hard to find the value of that by just having x be an exponent. So now if we use this property, and let's say we take the log on both sides, now we can move x to the front, and now as you can see, x is a real term, and now it's much simpler to solve for. All we have to do is divide by log 7 on both sides, and now we have the value of x as log 9 over log 7. So now I'm going to do the same thing with this. I had log base 2 of 2 to the power of x is equal to log base 2 of 3 to the power of x. So now if I move x to the front for both of these, I have x times log base 2 of 2 is equal to x times log base 2 of 3. Now log base 2 of 2, this is the same thing as 1. So now I have x is equal to x times log base 2 of 3. Now if I subtract x times log base 2 of 3 on both sides, I have these two cancel out. So x minus x times log base 2 of 3 is equal to 0. So now if I factor out x from this, I get x times 1 minus log base 2 of 3 is equal to 0. So the only value of x, actually now I'm actually going to go ahead and divide by 1 minus log base 2 of 3 on both sides. And these two cancel out, and left with x is equal to 0 divided by anything is 0. So x is equal to 0. This is my answer. Now to check, I have 2 to the power of x is equal to 3 to the power of x. So I know that x is equal to 0, so I have 2 to the power of 0 is equal to 3 to the power of 0. Now anything to the power of 0 is 1, so I have 1 is equal to 1. And because this is right, our solution is right as well. Alright, so I have 4 to the power of x is equal to 16. So now I want to find the value of x. So for my solution, first start with 4 to the power of x is equal to 16. Now, 4 here, this is the same thing as 2 squared. So now if I substitute in 2 squared for 4, I have 2 squared to the power of x is equal to 16. Now that we made 4 into a base of 2, I also want to change 16 into a base of 2 as well, because if both terms are the same base, then it's much easier to solve. So 2 to the power of what is equal to 16? Well, 2 times 2, this is 4. 4 times 2, this is 8. And 8 times 2, this is 16. So we have 4 2's, meaning this is the same thing as 2 to the power of 4. So now I have 2 to the power of 2 to the power of x is equal to 2 to the power of 4. So now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. So in the case of 2 to the power of 2 to the power of x, we can think of a as 2, m as 2, and n as x. So this would equal a, so 2 to the power of m times n. So 2 times x, which is the same thing as 2 to the power of 2x. So now I have 2 to the power of 2x is equal to 2 to the power of 4. Now, if I have something in the form a to the power of a is equal to b to the power of b, then this means that if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, 2x is equal to 4. So now I have a simple equation. All I have to do to solve it is divide both sides by 2. So then these two cancel out, left with x is equal to 4 over 2. Well, 4 divided by 2 is simply equal to 2, so I'm left with x is equal to 2. So now to check, I had 4 to the power of x is equal to 16. Now we have x equals 2, so I have 4 to the power of 2 is equal to 16. 4 to the power of 2 is the same thing as 4 times 4, and 4 times 4 is 16. So I have 16 is equal to 16. Alright, so I have 5x to the power of 5 minus 5x is equal to 0. Now, the first thing I'm going to do is I'm going to factor out 5. So if I factor out 5, I get 5 times, well, 5x to the power of 5 divided by 5, that's simply x to the power of 5. And negative 5x divided by 5 is simply negative x. So now this is equal to 0. Now I'm going to divide both sides by 5. So this way, we can just simply get rid of this 5, and it would be much easier to solve this equation. So now, these 5's are both going to cancel out, and 0 divided by 5, that's simply 0. So now I'm left with x to the power of 5 minus x is equal to 0. Now from here, I can go ahead and factor out x. So if I factor out x from here, I get x times x to the power of 4 minus 1 is equal to 0. And now this gives me two equations. I have x is equal to 0, and I also have x to the power of 4 minus 1 is equal to 0. So x equals 0, this is already a solution right here, so we already have one solution to our original equation, and we can find our other solutions from this equation. So x to the power of 4 minus 1 equals 0. Well, x to the power of 4, well, 4 here, this is the same thing as 2 times 2. So if I replace 2 times 2 with 4, I get x to the power of 2 times 2 minus 1 is equal to 0. Now, if I have something in the form a to the power of m times n, we can write this as a to the power of m to the power of n. So x to the power of 2 times 2 is going to be x to the power of 2 to the power of 2. And 1, this is the same thing as 1 squared. So I have minus 1 squared is equal to 0. Now, if I have something in the form a squared minus b squared, this is the same thing as a plus b times a minus b. So in this case, a is going to be x squared and b is going to be 1. So now I have x squared plus 1 times x squared minus 1 is equal to 0. So now this gives me two equations. I have x squared plus 1 is equal to 0, and I have x squared minus 1 is equal to 0. So let's first start with x squared minus 1 equals 0. I'm going to first add 1 on both sides, and these two cancel out, and I'm left with x squared is equal to 1. Now I'm going to be taking the square root on both sides. So then these two cancel out, and left with x is equal to the square root of 1, which is actually equal to positive or negative 1. So these are two more solutions to our problem. Now for x squared plus 1 equals 0, I'm going to subtract 1 on both sides. So now I have x squared is equal to negative 1. Now if I take the square root on both sides, these two cancel out, and I'm left with x is equal to, well, the square root of negative 1, this is actually equal to I. So now I have x is equal to I. So my solutions are x is equal to 0, 1, negative 1, and I. So these are my four solutions to this problem.